Good morning, students. So I hope all of you understood the chapter quadrilaterals properly. So if you understood the quadrilateral chapter properly, today we start another one chapter, which one is chapter number 13, and it is known as surface areas and volumes. So this one is another very important chapter, and in this chapter what we have to do? First of all, we have to find out the surface areas, as well as second time we have to find out volumes. Surface area. So far in all our study we have dealing with some figures which can be easily drawn on our notebook, isn't it? So that means this is known as two-dimensional diagram also, or plane figures. So that means these plane figures are rectangles, squares, circles, and easily we can find out the area as well as perimeter of rectangles, squares and circles, isn't it? So these are the two-dimensional diagram. So now in the chapter we deal with some three-dimensional diagram. Is it clear? So in two-dimensional diagram, if we consider the rectangle, so we get only length and breadth. Or in case of square, all sides are equal. So this type of figures, this type of formulas already we know. So we also learn to find the surface area and volumes of here cuboids, cubes and cylinder. This type of figures we have to discuss here, and some more figures we have to discuss like cones and spheres. Under the chapter we have to discuss these things in details. Is it clear? Okay. Now here the first one, as you see here written, what? Surface area of a cuboid and a cone. So that means we have to find out the surface area of a cuboid. So as you see here written, have you looked at a bundle of many sheets of papers? So as you see here the figure is mentioned. First of all, one paper, which one is look like as rectangle, and then when we look at this bundle, then this one is look like as what? Obviously this one is look like as a cuboid. So here already written that makes up a cuboid. How much of paper would you need if you want to cover this cuboid? Let us see. So now here the cuboid, that means the surface area of this cuboid we have to find out. Surface area. Now what is surface area? Actually we have to know first. Surface area means the boundary, the side, the faces. Surface area, the faces. So in a cuboid, first of all, if you imagine how many faces are there, so obviously 6 faces are there. So if you imagine a matchbox, and if you see the matchbox properly, then how many faces are we get there? 6 faces. So as you see here, if the first one you see, first we would need a rectangular piece to cover the bottom of the bundle. That means first of all we have to take a piece of the bottom one. Is it clear? Then the second one, if you see, then we would need two long rectangular pieces to cover the two side ends. So that means in rectangular piece we have to cover the two sides. And then the third one, if you see, now to cover the front and back ends, so we have to cover up this one. So now when we open a matchbox, if you see there, the bottom and the top is open and the other four sides are closed, look like as the figure number C, isn't it? Okay, now in this figure number C, how many faces we get? So this one is look like as you see the figure number D. So that means here total 5 faces are there. Is it clear? Then the last one is finally to cover the top of the bundle. We have to cover up the bundle and then total how many faces are we get, and there we get total 6 faces. Is it clear? And now if these 6 faces, if we write some name there 1 2 3 4 like, and then here we get, so we have 6 rectangular pieces to cover the complete outer surface of the cuboid, as you see here drawn here. Is it clear? Now this one, through the book we get here these 6 faces. So now here if we visualize this one with the help of 3-dimensional diagram, let's see how can we get this one. So as you see here the 3-dimensional figure of a cuboid, which one is A, B, C, D, E, F, G, H. So this one is a cuboid. And now if you see this figure here, now if you see properly here, this A, B, C, D, one faces here in this way. If you see here B, Z, F, C, another faces here. Then the third one is, if you see here Z, H, E, F, this one is another faces. Then H, A, D, E, this one is the fourth one. That means here total inside 4 faces are there. And the top, if you see the top one, then we write here A, B, Z, H, as well as the bottom one is here E, F, C, D, this one is the bottom one. So that means here total how many faces are there? Total 6 faces are there. So it is more easy to visualize the 3-dimensional diagram. So that means this cuboid, now here what we have to find out, we have to find out the surface area of this cuboid. That means for each and every faces we have to find out the area, and then if we count all this, that means total 6 faces, and easily we can find out the surface area. Is it clear? So now here one by one let's see how can we find out. So now here if the longest part, if you see the longest part, we write AH, or we can write BZ, is not it, as well as we can write DE, or in this side if you see we write CF. These 4 are the longest one. If you consider this one is as a length L, if we denote this one by L, then if we write this HE as height, or we can say ZF is height, or as well as BC is height, or AD is height. This one is we consider as an height. And if you see the AB is we consider as a breadth, or similarly DC or CD is the breadth here. So in this way if we denote, now if we find out the surface area of this ABZH, so in this case what we get? We get the breadth, AB means breadth, and BZ is what? Length. So easily we can find out the surface area, that means area of this top part, is not it? So in this case we have to apply the area of rectangle formula, and what you have to write? Then in this case we have to write length into breadth. Is it clear? Similarly, if you see here, if you find out the area of BCFZ, in this case BC is we consider as a height, isn't it? And BZ is the length. So how can we find our area? Length into height. So that's why if you see here the area of rectangle 1 as written here, length into height. Is it clear? So this type of length into height, we get another side. Which one? This one is length into height. We get ADEH. In this case also we get length into height. So if you see the area of rectangle 1 as well as area of rectangle 3, so in both cases we get length into height. Is it clear? Two faces. Similarly here, if you see here ABCD, this type of one faces, more faces are there, and which one is HCFE. So ABCD, in this case we consider AB as a breadth and AD as a height. So in this case what we write? We can write breadth into height, isn't it? So this type of breadth into height, two faces are there. One is ABCD and another one is EFGH. So we write two times. As well as if you see the top one, ABZH. In this case AB is the breadth and AH or BZ is the length. So we write here length into breadth if we find out the area. So this type of how many faces are there? Total two faces are there. One is CDEF, isn't it? So this one is the surface area of this cuboid. So if we count, if you calculate all this result, finally we get here surface area of a cuboid equal to 2 times of length breadth plus breadth height plus height length. Is it clear? Okay. So after getting the surface area of a cuboid formula, now next one is we have to find out the surface area of a cube. So cube is very easy. As you see the three-dimensional diagram here. In the same way, in a cube, total how many faces are there? Total 6 faces are there. And in case of cube, all sides are equal. That means total 6 faces and each faces area is how much? Side into side, a square. So that's why total how many faces are there? 6 faces are there. So that's why very easily we can write here. If we consider the side is a, then we write 6a square. Is it clear? So this one is the formula of surface area of a cube. Is it clear? Okay. Now this one is the formula of a surface area of a cube. Then next one is come here. Lateral surface area of a cuboid. So lateral surface area of a cuboid. So that means what here? When mentioned lateral, then the top and the bottom parts are totally open. Is it clear? So these two parts are not present. So that's why if these two parts are totally open, then our formula is we write here 2 times of length into height plus 2 times of breadth into height. Is it clear? So lateral surface area means the side, the 4 faces are we get, and the bottom and the top faces are totally open. These two are not included. Is it clear? This one is known as lateral surface area. As well as this lateral surface area also we can include for the cube. In case of cube, then what we get the answer is, if 2 faces are open, then we get 4a square. So these two are the formulas of surface area of a cuboid and surface area of a cube. Is it clear? So in our next class we have to continue this chapter and we start from exercise 13.1, and before 13.1 we have to do some examples. So in our next class we have to do this one. Is it clear? Okay, thank you.